Hello and welcome back to another session. And this time we're going to continue researching, studying Python, and we're going to enjoy studying it, researching it. So the last time I think I left it at this str.replace, and now we're going to continue. All right. So what's the point? Compiler now strip indents from doc strings. This will reduce the size of bytecode cache example.pyc file. For example, cache file size for SQLAlchemy.orm.session and SQL Alchemy 2.0 is reduced by about 5%. This change will affect tools using docstring like doctest. Contributed by this person and GH81283. Inada Naoki. Thank you very much. So this is it. So we're gonna ask Perplexity. Thank you very much, Perplexity, for helping us out on this. We're gonna ask Perplexity, what exactly does all this mean? All right, Perplexity, do your magic. Change where the compiler strip indents from doc strings, reducing the size of bytecode cache files. All right. So what I understand right now from this is that it's doing some things, and that's going to reduce the size of the bytecode cache. And it's also given an example that for the cache file size for this SQL Alchemy.orm session and SQL Alchemy 2.0 is reduced by 5%. So it's reducing the size of the bytecode cache. Okay. Alright, so it's reducing, so that is good. That is nice. That is awesome. What's next? The compile built-in can now accept a new flag, ast.py capital C capital F underscore. And let me see, what's a dash and underscore? Difference between this and this. Alright. So this is it. What is the difference between hyphen and underscore in the URL? Let's see if anyone has explained the difference over here. Well, first, underscore. All right, let's research about this underscore. Underscore character, also called a low line or low dash. All right, so this is an underscore. Underscore versus dash. Underscore, all right. Optimized AST, which is similar to AST.pycf underscore only underscore AST. Underscores are used to create underscores. Except that the returned AST is optimized according to the value of the optimized argument, contributed by Irit, Catriel, and GH108113. So what does all this mean? The compile built-in can now accept a new flag, ast.pycf underscore optimize underscore ast, which is similar to ast.pycf underscore only underscore ast, except that the returned ast is optimized. The returned ast is optimized. All right, yeah, okay, I can see it. So this is ast.pycf and this is ast.pycf as well. But the difference we can see is that this is optimized AST and this is only AST. So these two are similar, except that the returned AST is optimized. So this AST is optimized according to the value of the optimize argument. Nice, very nice. All right. Compile built-in. Okay, multiprocessing, concurrent.futures, compile all. Replace os.cpu underscore count with os.process CPU underscore count. So it's replacing this with this to select the default number of worker threads and processes. Get the CPU affinity if supported. Contributed by Victor Steiner in GH109649. Alright, so let's ask Perplexity once again. What does all this mean? What does all this mean? And the The provided search results discuss the use of various Python libraries for parallel processing and code compilation, and the recommended changes to improve the selection of the default number of worker threads and processes. And the recommended changes to improve the selection of the default number of worker threads and processes. The first part of the search result mentions the use of os.cpu count. Well, yeah, I do see os.cpu count over here. To determine the number of CPUs available on a system, which is then used to select the default number of worker threads and processes and libraries, which is then used to select the default number of worker threads and processes and libraries, such as multiprocessing and concurrent.futures. Okay, it's used to select default number of worker threads. However, the search results suggest that os.process_cpu_count should be used instead, as it provides a more accurate count of the number of CPUs available for use by the current process. The second part of the search results mentions the use of CPU affinity, which is the ability to bind a process to a specific set of CPUs on a system. This can improve performance by reducing the overhead of context switching between CPUs. The search results suggest that the psutil library. Is it over here, psutil library? No, well, it's not mentioned here. Why is it mentioning the psutil library? Let me see once again. psutil. I don't know. I don't see it. I don't see the psutil. psutil. Is it in the previous question? psutil. No, it's not over here. Okay, anyways. Compile all module. Yeah, I can see compile all module. Right, so the search results also mention a compile all module, which can be used to compile Python's works code files .python to bytecode files.pyc in a single step. Wow. So now today we know that compile all module can be used to compile Python source code files.py into bytecode files.pyc in a single step. The search results suggest that os.process_cpu_count should be used to select the default number of worker threads for compiling multiple files in parallel. And that CPU affinity can be used to improve performance by binding the compile all process to a specified set of CPUs. Overall, the search results suggest that using os.process_cpu_count and CPU affinity can improve the performance of parallel processing and code compilation in Python by selecting the optimal number of worker threads and processes and reducing the overhead of context switching between CPUs. All right, Perplexity, thank you very much. I understood this a lot, and it was a very enjoyable session. I learned a lot. I hope the watchers of this video also learned a lot. So today, where did we read it? Till what point have we understood it? So we did it till this point. Multiprocessing and contributed by Victor. Okay, all right, up to this. We've completed, we've researched, we've studied this until this point. All right, so that was very fun. Thank you to all the viewers watching this video. I hope you have a very good day. I hope you have a very nice day. I hope you live a very nice life. I hope you get all the luxuries of the life. I hope you stay happy. I hope you stay healthy. I hope you get all the good things in life. And I wish and I hope the best for you all. Thank you very much. Thank you very much. I'll see you another day.